My name is Marianne Weinke. I am with Hanford Mission Integration Solutions. Thank you so much for joining tonight's hybrid public meeting. We would like to remind folks that are joining virtually online to please mute your systems so that we won't have any interference with the microphones. We have also added the link to this meeting to the Hanford.gov events calendar, which also contains the meeting materials and the process for how to submit comments. And the comment period will be open through April 26th. This meeting is being recorded and will be posted to the events calendar. For those of us joining us here in person in the library, please note the exits in case of emergencies. We've got one here and one at the back. I can do a flight attendant sort of demonstration if you like. Tonight's meeting is on a proposed Class 2 permit modification to the Hanford Dangerous Waste Permit. If it is approved, it will continue the momentum in Hanford waste treatment operations. Our presenters are Matt Irwin from the Department of Energy and Suzanne Dahl from the Washington State Department of Ecology. They will give a presentation, and then after that, we will take questions, but please hold your questions until the presentations are complete. So Matt, I'm going to turn it over to you, and then you can hand it straight off to Suzanne when you're ready.
Yeah, we'll do a little bit of the tag team. So thank you very much. Good evening. Thanks for all of you for joining us this rainy evening. Before I make my introduction, I do want to acknowledge the three great people that sat in the front row. It's rare. Usually the front row stays people not sitting in it. But at the very end, you all three were brave enough to come and use those seats. So I'm just going to congratulate you. I promise I am not going to make you regret that decision. But I just want to point it out because it is unusual. Because sometimes we go through the whole thing and no one sits there. But my name is Matt Irwin, as was mentioned. I work for the Hanford Field Office. I'm the assistant manager for the waste treatment and mobilization plant. I'm also responsible for the overall Hanford Tank Waste mission. I've been here at Hanford for 30 years, so lots of experience here at Hanford. Love it here, and excited about sharing this proposal with you and answering your questions, and hopefully giving you a good understanding of what we're doing and why we're doing it. My focus will be technical, but I have my partner here from Washington Department of Ecology, Suzanne Dawn. I'll let her introduce herself. But we'll both hopefully give you all the information you need and work through any questions that you have. So, Suzanne.
Yes, I want to thank you too. I guess there's nothing better to do on a Sunday evening than come to a public meeting. Not a Sunday, it's a Tuesday. All right. All right.
That's fine, we have fun.
So I'm Suzanne Dahl. I'm with the Washington State Department of Ecology. I'm the tank waste treatment section manager. I've worked for Ecology doing Hanford cleanup work for 30 years. And I'm glad that you're all here to hear about the subject.
All right, thanks, Suzanne. We can skip to the next slide. And it's really just going to give you an agenda of what we're going to cover. Marianne's already done the welcome. Oh, we got you skipped. I thought that was still on the slide. All right, doesn't matter. Let's go to the Hanford site. I'm sure none of you have seen it, so I'm going to walk you through it briefly. You can skip down. There we go. Perfect. So shows the state of Washington, shows the 586 miles of the Hanford site. So just to give you context, we're starting at a very high level and working our way down. If we go to the next slide, we're going to talk a little bit about the waste treatment and mobilization plant. And when we get to that slide, it'll just show you our overall overhead layout, of which what we're focused on today is the low activity. Is it not switching over? Did it switch for you guys?
Yeah.
Oh, there it is. I'm sorry. It's my computer is slow. So I am through a phone on my phone, so my wireless is a little slow, and I don't want to make you guys feel weird by me looking behind me all the time. But I do want to make sure that the slide is up before I start to talk to him. So apologize for that. It's just a logistics thing. I will try to be more patient. I also will acknowledge, I know I do talk fast, so later on when we get to the questions, I promise I'll answer your questions, but I do tend to talk kind of fast. It's just one of my little peculiarities. So what this slide is showing is an overhead of the waste treatment and immobilization plant. On the left side are the portions that support the high level waste part of the tank waste mission. And those are in construction. As you can see, they're partially built and we're currently working on those. Those are not part of what we're talking about today, even though there's lots of exciting things going on there as well. We are focused on the right side of this picture, which is the low activity waste facility in the foreground. And then that is where we're actually making the glass and filling the containers. In the background is the effluent management facility, and that is where our secondary waste is goes to after it cools the different off-gas systems of the system, of the law facility. So those are the two facilities we're talking about today. This just gives you an overhead. They are in operating mode. We have been making glass since October, which is very exciting. But this is just to kind of frame you in. So we went from Washington down to the Hanford site. Now we're at the waste treatment plant. If we go to the next slide, we're going to talk about the overall direct feed low activity waste mission. And I know this is a bit of an eye chart. Certainly, I know you can't see it on the screen, but for those of you who have your hard copies, hopefully you will be able to follow along a little bit. And what this is showing, right, this is a overhead view of the 200 East area. That's that square that was on the Hanford site, about in the middle of the site. It's where the waste treatment plant resides, but it's also where the tank farms reside in East area that are the double shell tanks that are feeding the low activity waste facility. So if you look at the yellow line, it starts in what we call AP tank farm. It's one of the double shell tanks, tank farms, and the tank that we get fed from is located in that farm. That's where we have the pre-treated low activity waste that we are feeding to the law facility for glass. That's the yellow line. That yellow line comes down. As you can see, we have, it takes a 90-degree turn at the effluent management facility. The only reason that's important is it's a low point, no other reason than that, and it's not something you need to memorize, but I will be technical and I apologize for that. But bottom line is yellow line represents the feed that goes to the low activity waste facility. Once it gets to that facility, we sample it, confirm that we receive what we expected. We add glass formers, so that's a collection of chemicals that will take that material when we add it to the melter and it'll mix together to make glass. So we feed that to the top of the melter. It mixes in with the 2100 degrees molten pool that's already there. And then as we feed, then we pour out to the canisters. So that's the primary function. And those containers, stainless steel containers, that's where the glass goes, it cools, and that's our vitrified waste. But when we pour that material on top of the 2100 degree melter, it also has an off gas. That off gas comes off, it has anything that's volatile that's in the waste. That goes up through in a whole series of abatement trains. There's a submerged bed scrubber. It's basically a big tub of water, and you flow that hot gas through that. It's mostly air and steam. You flow it through that water, then it goes through a wet electrostatic precipitator, HEPA filters, which I'm sure anyone who's been on nuclear facilities are familiar with that. That takes out some of the particulates. Then it goes through a thermocatalytic oxidizer and a carbon bed. But each of those are to make sure we take the impurities out of the off gas so that what comes out of the stack meets our air permit and it's and those chemical constituents are taken out. Each of those components has a cooling function with it too, because obviously when it comes off the melter at nominally 2100 degrees, you want to cool it so you're not damaging the downstream components. There's cooling water in each of those systems. That cooling water is what we call the secondary waste. The secondary waste is represented on this graph that we're talking about by the white line, and that's really our focus tonight. We're talking about how we're managing the secondary waste. In a few minutes, I'm going to talk about the next level down detail of exactly the material we're talking about, but it's the secondary waste, some of which is already going down to our effluent treatment facility. That's primarily condensate, so that's the water that boils off as steam and then you recondense it and you send it down to the liquid effluent retention facility. And the material we're talking about is some of the materials that when you condense it, they're the heavier items, and we'll talk about that in more detail here in a minute. But this other piece I want you to get from this graphic is the integration. So tank farms is managed by one contractor. Today, the waste treatment plant and DFLAW, the low activity waste facility, is managed by Bechtel. And then when we vitrify our waste and put it in our containers, we send it over to CPCCO, which is the integrated disposal facility. And then our mission support contractor, HMIS, provides all of the infrastructure that's along the bottom. So it's just to show the integrated effort that goes on as we're making glass and performing this part of the tank waste mission. But it also shows how the materials are transferred from tank farms to law, from law for secondary waste, and then the actual containers that go to the integrated disposal facility. So just trying to give you that context of how the facility operates. So we'll go to the next slide. Now we're going to talk about the overview of what we're proposing here. The effluent management facility is where that white line, after it leaves the low activity waste facility, it goes over to the effluent management facility. It has an evaporator in it. That's where we take those liquids, boil off the water, and send that condensate to the liquid effluent retention facility. And then the stuff that stays at the bottom of the evaporator, we call that the bottoms or the concentrate. That's the material that and we will still have this function, by the way. Our original design said we would typically feed that back into the melter. And instead of feeding more AP 106 waste, we would, more tank farm pre-treated law. I apologize, I'll talk about the tank, and I know that's just inside baseball, as it were, but not that it's a bad thing. But that material, we would feed that back into the melter. What we found is that material, the radiological contents are quite a bit lower than we expected. And it's much more benign than we expected. We will still be able to feed it to the melter if we have materials that come through that have some anomaly, and we will continue to sample it that way. But we're proposing an alternative approach, which would be that if we take that material, sample it, put it in a tanker truck and send it down for grouting, and then outside the state of Hanford disposal, that will allow us to, instead of sending that material into the melter, it allows us to increase the amount of the pre-treated tank waste we get from tank farms. So the intent is it's accelerating our mission, because it will get about a 10% to 20% increase in the feed to log coming from tank farms, because this material would then go to grab. And if we run into a condition where we have a sample problem or some other reason, or it's elevated, then we can send it into the melter just like we do now. So, and I'm going to talk a little bit about that capability. The system is designed to be able to do this, and it was a potential option. It just wasn't originally written into the permit because we hadn't made glass and we didn't have the actual data. It was all based upon modeling. So now that we're getting real data and we're looking at it, it looks like a favorable approach. It allows us to accelerate the mission, and so that's why we're doing it. Suzanne is going to talk a little bit more detail here on the regulatory framework, but the bottom line is we get together with Washington. Can work this way.
The phone feed is cutting out.
Thank you.
Yeah, we're working on them.
Yeah, I apologize. We'll work on that part of it, and we'll make sure we cover the material. One more slide forward. Okay, so the first bullet we've already talked a little bit about, which is the multiple facilities that are involved. Yeah, thanks, Colleen, for asking that. The secondary waste is covered in the second bullet. And as we talked about, it goes to an evaporator, the steam that's then turned to condensate is sent down to our liquid effluent retention facility and the effluent treatment facility. And then the portion that the heavier elements that are at the bottom of the evaporator are then put in a separate vessel that then we can either feed back to the melter, or we can put it in a truck and then send it out to be grouted and then disposed of outside of state of Washington. So that, and the last bullet is that EMF bottoms or concentrate. So I'm using both terms because they've been used interchangeably from a layperson standpoint. So if we can go to the next slide, I think that'll show us our graphic. Oh, I'm sorry, I need to talk about benefits. And we talked a little bit about this is, the reason we do want to free up double shell tank space is because right now we're 97% full of our double shell tanks. We have been making glass, so we just finished a 2-week run on the melter, and so we are making glass and filling containers, and that's great. But the faster we do that, the more double shell tank space we make, the more double shell tank space we make, we allow ourselves the opportunity to accelerate our retrievals, which today we're doing 2 retrievals, and I know that's not part of today, but that's why we want to maximize that double shell tank space so that we can continue our single shell tank retrievals and continue our mission. And at the end of the day, finish our mission. So that is the single biggest benefit. It does not take away the ability to still feed the melter if, like I said earlier, if sample results or something changes, we may get to the point where we're feeding the melter and the secondary constituents change, and that could lead us to feeding it back to the melter, and that's fine. But for those opportunities when we do, it'll be at least a 10% increase in our throughput from tank farms, could be as high as 20%. And then just meeting our legal commitments, right? The better we can accelerate our retrievals and our other activities in tank farms, it puts us all in a better place. And then the final one here is really operational flexibility, which is having the options to use the melter and refeed into the melter when that makes sense, or go and grout it, that's what the sample results tell us today. That's what makes sense today. And it doesn't change our safety posture. And once we've gotten through the process, then our permit will describe everything we're doing with any necessary changes. And Suzanne's going to go in a little bit more detail on that here in a few minutes. All right, now we're going to do what I think is the funnest slide, and that is this graphic. And so hopefully I will do it justice. So if we start really, it's in the middle of the picture, which is the melter feed. It shows just to the left of that vessel, and I only do that because I know it's kind of a square with rounded corners, but that's a vessel. The raw waste feed, that's what's coming in from tank farms. It goes into that vessel and it gets added with glass formers get added to it, gets mixed, then we get sampled to make sure that we are feeding the melter what we expected. And then it shows the waste feed. Now it shows it at the bottom. In reality, it's feeding from the top, but that's for illustration purpose. We have feed going in the top and off gas going out the top. So this just shows the feed going in the bottom, because then you're not confused, because the off gas absolutely comes out the top, and that makes perfect sense. Coming out the bottom of the melter is that representation of the glass, and that's the glass being fed into stainless steel containers. Once those containers are filled, they're lidded. Surveys are performed, they're put on a truck, and they're sent to the integrated disposal facility. None of that changes. So all of the primary waste that's going into the melter and vitrified is exactly the same. Off the top of the melter, as I mentioned before, any water that's in the waste flashes to steam. Any of the volatiles or any of the other things that go up with the steam go up through the off-gas system, and it has multiple trains. Each of those items in that train have cooling, secondary cooling, and that's to protect it from the high temperature of the glass and the off-gas that comes off of that glass. Once it goes through all of that, it goes up through the stack, which is being monitored. We went through our extensive environmental performance demonstration test. It continues to operate exactly as designed and consistent with the testing that we did back in July, August. Seems like years ago, but it was only last July and August. And then the part that's going to the right is that secondary off-gas cooling water. That goes down to the effluent management facility. It goes into an evaporator, and we aren't showing the part that goes down to LRF, but if we were to put another arrow at the top, that's the condensate that comes off that evaporator. It goes down to the LRF facility. The change we're talking about is that bottom line coming out of the effluent management facility to the left. That was the function that's currently in the permit. We will still be able to do that, but this change adds all of the functions to the right of the effluent management facility. That would be transferring it out to a tanker truck, having that tanker truck go down to Perma Fix Northwest to be grouted, and then from there, Energy Solutions would take it for disposal outside of the state of Washington. So this graphic shows all of the things in graphical form that we talked about here a little earlier, and hopefully it's very clear. So that's a summary of the overall process. If we can go to the next slide. And so basically what we're doing is we did a class 2 permit modification that describes all of these changes. And so like I said earlier, the second bullet, Suzanne's going to talk in a little bit more detail, and we can go to the next slide. Here, and the real fun part about this is that picture is literally the truck transfer station adjacent to the effluent management facility. So on the right side, you see the vessels. There's a few outdoor vessels and there's a few inside the building where the evaporator is. But that's the effluent management facility on the right side of that picture. And then right in front of you with the sealant, the yellow sealant on the truck transfer area is right there in the middle of the picture. And the systems are already there. We had to use it during cold commissioning because we had materials that we were putting in the system to test it that were simulants. Those simulants we had to put in tanker trucks because it makes sense to run them through the effluent treatment facility. So we have used it before, not for this function, but we have used it, and now the permit will contain the controls to manage that spill containment as well as the overall system. And as I stated, the second bullet, the whole purpose of this is to accelerate our vitrification of tank waste, pre-treated raw tank waste, to accelerate the overall Hanford site cleanup. All right, next slide. And here's where I hand up to Suzanne, and she will carry us through.
Okay, we can go on to the next slide. All right, so there's several permits and licenses that cover the waste treatment plant. The Department of Health has radiological licenses, and Department of Ecology has air permitting as well. But the permit that we're talking about here is the dangerous waste permit that manages how the facility manages and treats the dangerous waste, the chemical waste that also happens to have radionuclides in them. So how did we get to here? Well, and Matt talked about it a little bit. Originally, when we were first looking at all the different waste streams coming off of the plant and looking at the modeling and looking at the risk assessments, it was thought that that what would be in the first part of the wash of the off gas and the scrubber waters of the off gas that would have quite a bit of radionuclides in it and quite a bit of other things that would drive the risk. And so things that are mobile in the environment and that are long-lived. And so from those risk assessments, we found that the best thing to do would be to recycle that waste past the melter over and over again so that you got more and more incorporation of those constituents that were risky into the glass. So what's different now? So that option still exists in the permit and it's still a viable option. But there are a couple of things that Matt mentioned. One of them, one thing that's different is right now, the sampling is showing that there's not the concentration of constituents that are risk drivers in the landfills, and that we thought. But the other thing that's different is when we were first looking at this, we didn't have an offsite disposal option. And so now we do have some offsite disposal options because where does most of the secondary waste from and the low activity glass and most of the secondary waste from the waste treatment plant goes to a landfill that's adjacent, so that's co-located out in the 200 area. And it's called the Integrated Disposal Facility, or IDIF for short. And the glass does a really good job of retaining constituents. And the other secondary waste that we are talking about here is appropriate for the constituents that were in that waste. Now, this waste, if this waste that we're talking about, the EMF concentrates, the bottoms, if you follow what was in the modeling, it's probably not appropriate to dispose of it at the IDIF landfill. And for that reason, the IDIF landfill has a permit condition that says that the EMF concentrate bottoms can't go to that landfill. But then the Department of Energy proposed, okay, what if, for efficiency's sake, we could take the EMF bottoms and grab them and take them to off-site disposal, to a disposal facility outside of the state of Washington. Therefore, it wouldn't be adding to the risk burden here and to the landfill here. And so that, after we considered all those options, we thought, okay, it's a good option to put in there. Yet you still can recycle, past the melters and get incorporation, or you can take it the path that Matt just spent time describing, and it can go to off-site disposal after it's grounded. So we put a series of, the permit's divided into chapters. There's 9 or 10 chapters in each permit. And when you go through a permit mod, you look at where a permit modification, you look at where you need to change the permit to match the new situation. And so I'll just go over them in case you want to review the permit and in case you want to develop comments, which we would encourage, you can know where you're looking. So in chapter C, which is the chapter 3C, which is the waste analysis plan, there was a small change that was adding a sampling point at the effluent management facility. And then in chapter 4, which is the process description section, there were several adds. There was a description added to describe how they were going to transfer the waste. And then there was also a new section added to describe how they would load the waste into the tanker truck in the truck bay that had the picture of. In addition, there was another section added to describe the EMF sump, because if there was a spill, then waste would go to that sump. And then also equipment that would be used for controlling a spill or that could occur, hopefully not, in that sump. So currently, those details weren't in the permit, so we needed to add those details in. And then there was also instrumentation details added to the permit about the EMF truck-based sump. And then to the next slide, please. And then there was some changes to chapter 6, which is the process to prevent hazards. There was some descriptions and requirements added to make sure that somebody couldn't inadvertently go into an area that they shouldn't be in. And since this facility wasn't previously being used in this way, then those requirements weren't needed, but now they are. There's also, again, some spill and leak prevention measures added in the prevention to prevent hazards. And then there were 3 figures that were modified to show how postings would change. And that's, again, part of preventing somebody from inadvertently going where they shouldn't. And then the inspection plan was changed. So now that the EMF truck bay was going to be used this way, there needed to be daily inspections. And so that was added. And then in addition, some of the drawings that look at all this were added. There was one drawing was updated. It's a piping and instrumentation drawing. So it's a diagram that shows where the piping goes and what piping goes where. And so that needed to be updated. And then the last thing, those are the chapters of the permit that were affected. So not, I think I counted 6 out of the 9 or 10 chapters had small impacts to different tables and different diagrams. And those are all shown in the permit modification when you go look at it on the web. And then in addition, Department of Ecology worked with the Department of Energy to develop some permit conditions that would now address this new approach to things. And so there was a permit condition that was added to talk about when it's appropriate to recycle and when it's appropriate to have the EMF bottoms go up for off-site grouting and off-site disposal. There was also then a series of permit conditions that looked at sort of some controls around that. So the first thing is there's a permit condition that says that that the concentrates will go for off-site disposal, and that's needed because it can't go to the integrated disposal facility landfill. There's also measures to prevent an orphaned waste. So what's an orphaned waste? Well, if the grout can't be disposed of here, then we don't want to build up a large sum of grout and then it not be able to go to the landfill where it was supposed to go. And so when would that might happen? This is sort of ecology putting its worries, its worry sets out there and just trying to prevent any future concerns. And so, for example, if the landfill that it's supposed to go to were to have some sort of issue and to close down or maybe just be temporarily closed, then this permit condition would prevent large amounts of grout building up during that time. And they would switch to recycle during that time. And that way we don't have some grout that doesn't have a home. And so that was that one. It was also, we put in a limiting volume of 87,000 gallons per year, because that's what we had current documentation in the environmental assessments to justify. We also did put in a permit condition to allow them to expand that when it needed to be expanded, and it likely will need to be expanded. And there'll have to be additional analysis done to show us that can be done safely and compliantly. And then also, we want an update to the mass balance. Right now, there's a mass balance that runs in the background, and how much of a particular constituent ends up in the glass or ends up in the carbon beds or the HEPA filters or off here to the concentrates in the bottoms where we're talking about. And so since you're changing the process flow, and this is not going back into the melters, you're potentially changing the mass balance. And so we've asked Department of Energy to redo the mass balance, and it may very well show that there's not really much change at all, but we just thought that the mass balance needed to be updated. And that's the end of sort of the description of the details of the permit and what changed in the permit.
Thank you both for those presentations. So now it's going to be time for us to do some question and answers. If you are joining us virtually and you have a question, you can drop it in the chat and Colleen will read it. Again, please remain muted at all times unless you are asking a question. If you called in using telephone only rather than Teams, you are muted, so you would have to press *6 to unmute, and then you would return to muting by pressing *6. Also, we would ask that if you have multiple questions, whether that's online or in the room, please save them until everyone's had an opportunity to at least ask their first question. We will circle back, but please stick to one at a time so that everybody gets a chance. And also, if you wouldn't mind stating your name, and if you're representing an organization, please share that if you'd like. We do have microphones. Again, that might be for the folks online. It's not just about whether you can talk loud enough for the people in the room, but we are, as I mentioned, recording. So we have folks that will bring a microphone to you if you have questions. So with that, I think we can get started. Do we have any questions in the chat?
We have one question in the chat so far. The first question is from Liz Matson. Her question is, actually, I had another one that just came in, so we'll get to that one too. But Liz's question is, what is the quality of liquid in the EMF bottoms? Is it thick liquid? How does it differ from the liquid that goes to LURF?
All right, thanks, Liz. Thanks for the question. So the density is a little bit higher than pure water. So the condensate that comes off the top of the evaporator is pure water. The bottoms would have any particulates or other things that come across in the off-gas stream. So it's a little bit more dense than water, but it's not a very high density. So it's just a little bit over water. It has small amounts of cesium, very low, so quite a bit lower than what goes into the glass. It also has a little bit of technetium and a little bit of iodine, but it's a very, very trace amounts, just above measurable. Still certainly wouldn't you want to put it in your drinking water, but they are very low quantities. I don't know if you supplement that, Suzanne. Yeah.
Right, I thought I saw a hand start to go up in the audience. Did someone have a question?
Oh, there's one. Oh, two. All right.
We'll kind of rotate between online and in the room.
Hello, my name is Frank Hospidoni. I'm just a member of the public here. Could you give us like a relative risk of like one of these tanker trucks if it was to get in an accident? Like, is it more or less dangerous than like an oil tanker getting into an accident?
So the only thing I clarify first is I would say just the public. So you're definitely a member of the public, but not just. But to answer your question, it would be well below that. So this is what would be considered a Class A shipment, which is the lowest level of a Department of Transportation radioactive shipment, well below a oil tanker. I mean, so it's a little bit more radioactivity than an oil tanker, but from a hazard standpoint, the hazard for that would be a lot higher. So not to say that it's zero, but it would be low.
All right, so our next question is from Jeeve. I need to scroll up here. All right, so Jeeve Macon, please discuss the off-site grouting facility and its readiness for this project, both in terms of efficiency and safety. Some question for the tanker trucks involved, or same question for the tanker trucks involved. So yes, that was his question.
Sure, no problem. Yeah, so this work is being performed, the work from the effluent management facility, so everything in the low activity waste facility, the effluent management facility, that's managed by Bechtel National, so that's a direct contract with DOE. All of the work transferring to the tanker truck and then beyond that, that's overall managed by Energy Solutions. So that's one of the contract, it's a subcontractor or a prime contractor, not that that's important, it's a contractual thing. But they are the individuals, they provide the tanker truck. They take that material after we've transferred it into the tanker truck, they take it to Permafix Northwest, which is here in North Richland. I have visited the facility, I know they do good work and they've done a number of things for the tank waste mission. So I can't speak specifically to their safety other than I know they do safe work every day and do work on our behalf for multiple things in the tank waste mission. They are the ones that would grab the material. Then that material is picked up by Energy Solutions again and then taken for disposal at Energy Solutions disposal facility in the state of Utah. So the truck and the transportation, as I mentioned earlier, would be done as a Class A Department of Transportation shipment. We know that they meet all of our safety requirements and associated standards as defined in their subcontract to perform that work.
You just opened me because we don't have.
I saw another hand up in the audience before. Okay, there we go.
So the water and sediment that currently goes to the landfill in Oregon and Idaho, is that no longer going to go there? And is that going to go to grouting instead?
So those were materials that were associated with coal commissioning. So that was all part of the testing process before we actually added the radioactive feed from the tank farms. So there is no longer any materials that are going to that landfill, as that was part of our commissioning process. So now the only places it goes is if it's turned into glass, it goes to the integrated disposal facility. If it's the condensate that goes to our on-site 200 East effluent treatment facility. And then as Suzanne pointed out, which I failed to mention, which is there are some byproducts of that that also go in the integrated disposal facility. And then the last option is these EMF concentrates. When we initially started up, and we've been doing this so far, we recycle it back into the melter. This would give us the option to send that down in a tanker truck, get grouted, and then sent to a disposal facility in the state of Utah.
So no more landfills in Oregon or.
That is correct. Yeah, that was part of the commissioning, but that was before we introduced radioactive material to the facility.
Colleen, is there another one online?
Yeah, we actually have, we're getting a list here, so I'll let you know we have Adam, Dan Solitz, Nia, Simone, and Mark so far in the queue. So Adam will come first and then Dan. So Adam asks, what reasonable attempts to system tuning have been attempted on the secondary liquid effluent generators, caustic scrubber, and the EMF evaporator to minimize the volume of bottoms produced?
Yeah, so that goes way back. That goes back into our testing and the environmental performance demonstration tests we did, which was to make sure that the constituents that can come off the melter get mitigated by each of those abatement trains, that those take the materials off. And from a tuning standpoint, that's now that we're operating the plant with feed from tank farms, we are looking at optimizing that through I'm sorry, I'm gonna get into more technical things, but how we add the glass formers. Right now, we're using more water than we would prefer, so we have a modification that'll use less water, which means less steam, which means less secondary waste. So that's one of the optimizations that we are doing. We are fine tuning the sodium molarity of the feed, and I know you say, well, what does that matter? Well, that decreases the amount of water that's going in, which decreases the secondary waste. So these are all part of, now that we're actually adding the radioactive feed, we're doing sampling, validating that those results are within the modeling, and all of them are well within the modeling, so that's a good news thing. And now we're also making tweaks to how that feed is. Like I said, if it's a higher molarity, it means less water. Less water means less steam. So those are the kinds of adjustments we're making along the way. And each of those abatement train pieces have adjustments that we make on how we operate them. Some of them don't need as much cooling water as we originally intended, and some actually need a little more. But those are all the adjustments that go along with the answer to that question. And it's a lot more technical, but that's the kinds of thought processes we're going through.
All right, our next question is from Dan Solitz, and I think Dan wanted to ask the question himself. So can you unmute Dan and ask your question?
Hello, can you hear me?
Yep, we can hear you. Thank you.
Okay, earlier on you mentioned something about the double-shelled tank. You can't create any more room in them. Is that because they're full of everything but supernate? Or is it because the evaporator, the big evaporator is in the circuit anymore, or what? I'm not quite sure what's going on with the double-shelled tanks.
Okay, so, and I didn't hear the very beginning of that, so if I didn't capture that part of your question, then please just let me know. But the double shell tanks have been filling as we've been retrieving from the single shell tanks. The evaporator that you referenced, we do continue to use the evaporator, but it becomes less effective the more we concentrate the waste that's in the double shell tanks today. So we do still use it. They did, our contractor did 5 campaigns last year, freeing up 1.1 million gallons of double shell tank space last year. But we also have completed retrieval of 1 single shell tank, and we're in the middle of 2 more. So that's used up that million gallons. So that's a good news story. The bad news story is we're at 97%. We want to make more glass. We're working to make more glass, but this just gives us an opportunity to bump that up and do it a little bit faster. So yes, the evaporator is still in the equation. We have a campaign for the evaporator later this year. So we will continue to use it, but to the degree we're able to use it depends upon the density of the waste that's in the tanks. And so it can't be used to wholesale to free up space, but we use both of those tools to the best of our ability. Did that answer? Because I didn't want to make sure I didn't miss what you said at the beginning.
Well, I've got a little follow-on question. So where is most of the supernate? Is that in the single shell tanks?
No, supernate's in the double shell as well. But the double shells have, you obviously have a little bit of knowledge because the double shells contain whatever solids are in them, as well as the supernate at the top. But the density of that supernate varies from tank to tank, depending upon how much solids or salt cake are in the tank. So that limits our ability, or I won't even say limits. It controls how much we can use the evaporator to free up space.
Okay, thank you.
No problem.
All right, our next question is from Mia Burke. Her question is, what are the estimated number of shipments and estimated shipment schedule for how long this project will be.
Yeah, so in the short term, that's hard to predict. Over the last nominally 2 weeks, we average about 2,000 gallons of vitrified waste a day. I don't know the exact numbers of our secondary, but I do know we have about 15,000 gallons of EMF concentrate. So if we started today, we'd probably doing, when we're operating, when we're making glass, which I would like to be every single day of the year, 365, but we do have to shut down and change heating filters and do maintenance on occasion. But that is my goal. I would say based on what we're operating today, we'd probably do a couple of tanker shipments, and then it'd probably be, 1 or 2 a month based on where we are today. But we are ramping up this facility. That is part, by the way, I don't want anyone to walk away feeling like, oh my goodness, this is a bad thing. We always knew we wanted to start up this facility in a very systematic way. We took a whole bunch of samples of the secondary waste in the front end as we were first starting up, because we wanted to establish a very solid baseline. So we did that in a very systematic way. Now we're starting to try to go longer time periods, run the plant longer, make more glass, get a better idea of that secondary waste when you're running for longer periods of time. We hope over the next year to get somewhere around 1 million gallons. So if you do the math, that's 100,000 gallons, 100 to 200,000 gallons of the bottoms that I'm talking about. As Suzanne stated, right now this permit would allow 87, so that probably supports everything we would do this year. But we're going to make sure we continue to sample. We may find that some fraction of what we feed back into the melter, so we may not use that entire 20% I talked about, but we also might. So I don't really want to predict exactly how many shipments, but it gives you an idea, right? It'll be somewhere between 10 and 20% of our production. We hope to get to 1 million gallons of glass here at the end of the first year, and then get up to our overall capacity closer to 2 million in the second and third year. But we're going to do that safely. We're going to do that as the plant supports that and make sure that we know what we're doing every step of the way. So I can't give you the exact number of shipments today. I can tell you we would do at least 3 if this permit were in place today. And that's probably where we'll be when we actually get it done, because we will be feeding that, recycling that until the permit is through the system. So it'll probably be around that amount when we start, and then it'll be less over time.
So it's about 7 to 10,000 gallons a month on average, right?
When we're running the plant on a regular basis, that's right. And I'm sorry, I know that sounded like a roundabout answer, but it's as we're ramping up. I don't want to give anyone the impression that we are starting at full bore.
Carmen Higgs, I had heard that initially that grouting is a more energy efficient process compared to the vitrification process. I was wondering if that probably didn't account for transportation, but I was kind of curious if that is also a benefit.
So that is a true statement. So it takes a lot of electricity to keep that melter at 2100 degrees. And it's a more complex process. But it is glass, and we know glass has top tier capabilities as far as putting the material. It doesn't mean grout's a bad thing, by the way. But your question as to whether it's more energy efficient. It takes less energy to grout the material than to put it into glass. That's a fair statement. I'll let Suzanne add to that.
So not so much thinking about energy, but thinking about the different benefits of the different options, right? So when vitrification generally reduces the volume of waste, but it produces secondary waste. So, okay. And then grout increases the volume of waste by about 3 times. And grout has to go for offsite disposal, so there's that cost there too. And it has 3 times the cost of disposal if there's 3 times as much. So, but then a grout plant is presumably cheaper to run than a vitrification plant. So, but you have to look at the whole picture, right?
Yeah, good supplement, Suzanne. Thanks.
All right, our next question from online is from Simone. Her question is, how many samples of EMF bottoms concentrate have been taken since October? Is the feed all from the same waste batch? And since October, how many gallons of EMF bottoms have been recycled?
Okay, so let me start at the beginning. I can't tell exactly the number of samples. We've done multiple sample campaigns. It's 30 or 40 constituents for the three DEP 3 vessels. For the secondary vessel, I know that number is 162 individual constituents we look at. I know for the secondary, we've done 13 batches, I think, something on that order. It's above 10, but less than 20. So I know that for sure. And for the vessel 3, because we've been feeding them back into the melter, we don't have to do as much extensive sample, but we've done multiple sample campaigns of the vessels that we're talking about to establish their baseline. Oh, so the next part of that question was, I'm sorry, I know there were multiple parts.
Sure, okay. So let's see, is the feed all from the same waste batch?
Yes.
And then since October, how many gallons of EMF bottoms have been recycled?
Yep, great. Okay, thank you. I knew there was another piece. All right, so the feed tank was almost full, about 80% full when we started. It's all come from that same campaign of the feed tank. So all of the materials we're talking about are from that same campaign. And it's between 3,000 and 5,000. It might be 3,500, but we've done, I think, 3 times that we fed back into the melter. I think it's in the 3,000 range, spread around there.
Yeah, total.
Oh,
Total,
yeah.
I pulled it up. Total EMF recycle is 6,000, that you produced is 6,700. And you recycled some of that, so.
Thanks, Suzanne. She's looking at the dashboard. I was trying to go from memory, so.
Matt, can you repeat what she said in the microphone?
Yeah, so the total produced is 6,000, and then, yeah, our year to date is 3,745, so I was way off. Couple hundred gallons, which by the way, for me, that's a success. I'm calling it a success.
All right, our next online question is from Mark, also having to do with the concentrate volumes, but I'll read his full question. Can you discuss what the total EMF concentrate volumes would be in gallons, assuming the DF-LOB plant runs at the 1 million gallon per year target? And then the continuation to that question, is it over 332 cubic meters? Also, does increasing tank waste feed into the DF-LOB plant by 10 to 20% generate more solid and secondary waste?
Okay, so you may have to give me pieces of that, but the overall would be for 1 million, if we do 1 million gallons, which by the way, we will be working to well over 1 million, closer to 2 million over the next couple of years. But if we were operating at 1 million, it would be somewhere between 100 and 200,000 gallons of the EMF concentrate that would come out of that. It is higher than the 332, which is 87,000. And as Suzanne pointed out, as we get additional data, we may request some additional volume. But we would, just like I talked about earlier, we would sample that material. We would continue to have the option to recycle as we have so far. And if we find that that is a beneficial one, is providing both the benefit without increasing risk, then we would request an increase to that 332 cubic meters, yeah. By the way, for anyone asking questions, if you change units on me, you're making it harder for me. But it's okay, but I'm just saying. And then was there this last part of that question?
Yeah, the last part was, does increasing tank waste feed into the DF-LOB plant by 10 to 20% generate more solid secondary waste?
No, it'll generate the same amount. Because if we were feeding the EMF concentrate, it would also create secondary waste. It's really about all of those cooling systems on the abatement train. So whatever you put, however much you put in the melter, there's a fraction of that that's going out through the secondary waste, and that stays gone. Well, it's a constant ratio, it's not a constant number. Is that fair? You can.
Yeah, and I think that's accurate, but that's one reason why we've asked for the revised mass balance too, because it won't really change so much what's coming in from the tank farms to the melter. Well, it does, it's more concentrated because you're not diluting it with EMF, recycle. But then the question is it makes good glass no matter what, we know that. The question is the mass balance will just show us how the what's going to the off-gas train in a different way. And whether there's so much more of something going to the carbon beds or the HEPA filters and.
That's right. So to answer that part completely, right, we have isotopes and other materials that are going back to the recycle. And what Suzanne's saying is, instead of just going into recycling, some of them may recycle more than once, some of those constituents. But doing the mass balance will then say, okay, no, we took those out, we took X out in grouch, but what did that mean for the rest of the secondary loop and what went in glass? Or the abatement train, as Suzanne pointed out. But the overall ratios of volume of liquid should stay generally the same, but the constituents might vary a little bit. And I'm sorry, I know that is more technical than people ask for, but.
Our next question is a couple of follow-ups from me and Burke. So I know, Mary Ann, you wanted to get first questions first, so.
I'm about to say, are there any questions from the audience?
I'm Scott Hanks from the public. I just want to congratulate you on so quickly coming up with an efficiency after starting the process. I just wondered if there's any other efficiencies that are kind of lurking in the background that may come up.
From a permitting standpoint, there aren't any right on the forefront, but I will say there are ones that are not permit related. I mentioned them earlier. One is changing the molarity of the feed, which we believe will improve less secondary waste and just improve the overall flow through our ability to feed the melter. So that's one. There's a second one. Oh, I'm sorry. It's the different pieces of the abatement train. So dialing in how those are being operated, how much, because some are requiring less cooling water, some more. So that's just another benefit to dial those in and get those aligned. And honestly, so what I tell my team is we're learning the personality of the plant. We learned it when we were cold. Now we're learning it as we're feeding rad feed, and we want to understand it like the back of our hand so that we make adjustments. And over time, right, we're going to get some other, there was a question earlier about batches. Some batches are going to be a little different, and we want to be able to make adjustments when those new batches come in. See how the samples change. If that means we recycle, we recycle. But we want to get to that level of maturity so that we understand, we predict and know what the changes should happen, and then when they do happen, we've already made the adjustments. So that's kind of where we want to get. That's why we're a little more systematic now and a little bit slower in ramping up our feed, is to make sure that we do this in a systematic, safe way.
Well, you could talk about it, but managing your in leakage into the melter is another efficiency.
Yeah, so we have had, so in leakage is just the air that's leaking into the melter. That obviously, if you have more of that, it causes the fans to work harder, it causes more flow through the system. So we have on multiple efforts to go decrease that in leakage. Because that it also improves our ability to feed the melter. It improves our ability to control that. So we keep it in a vacuum, and the tighter it is, the easier it is to make a vacuum. So those are some other improvements that we've been doing. So this is all part of, and it's in my vernacular, learning the personality and trying to take full advantage of the machine. And at the end of the day, make the maximum return on investment so that we get the tank waste mission done. So that answers the question.
Okay, Colleen, I know you said there were a couple more online, so why don't you give us one of those? And then I know we have someone in the audience that we'll come back to as well.
Okay, so the next question for Mia Burke. Let's see, have you done cost estimates for making this change to the plan? Do you have the budget to be able to make these proposed changes immediately?
So the answer is yes. The subcontract is in place, and we know what those costs would be. We will be funding those through cost savings on some of the others. So on the front end of this system, I talked about the feed tank. In the tank farms, we actually pre-treat that waste to support that feeding. We have some efficiencies from our operating contractor on tank farms on how we run the system that does that pre-treatment. Originally, our outages were 30 days and our ability to put material in the ion exchange media, we've had some improvements in that as well. So those leads to some savings that then allow us to be able to fund the grounding activities we're talking here. Now, as we expand that, we will be looking for additional efficiencies, both on the front end and the operating of the low activity waste facility to help support that. But yes, we are funded. We do have the subcontract in place. We could start tomorrow, but obviously we want to go through this process and give everyone an opportunity to give feedback and before we ultimately make the decision and move forward. So that's just where we are in the process. There was a hand somewhere.
Yeah.
Yep.
Okay, so sampling, I see that on the permit. Where will the sampling be going? Is it gonna expand? Is it still, some of it's gonna stay on site, some of it's going out of state? Expand on how sampling.
So we originally were using some labs out of state, but we've been working to do as much of our sampling and results in the analytical lab that we have in the waste treatment plant. I can't tell you that it's 100% on site, but we've been working towards doing all of the sampling through our analytical lab. That means getting all the right training and qualifications and equipment. We started out with dual samples with labs, like I said, outside of the state. I'm not sure we're at 100% on site, but we're working towards that. And I don't know, Suzanne, if you have any more on that.
And then also you use 222S lab as well.
Yeah, and so that's a good point, because I consider that on site, but it is a really good point. So the 222S lab, which is run by Navarro, is our on-site lab that does our tank farm samples, and they are doing some subset of those samples as well. So they're not all within the waste treatment plant itself.
So using private aircraft to send out samples for testing?
Yeah, no, we don't have any of that going on anymore. That was our initial set of sampling for establishing that baseline I talked about at the beginning. So I know we don't have any that are being shipped via air anymore.
So that's gonna stop.
Yeah, that's stopped, and we're doing there may be some labs off the Hanford site, but they're not on the other side of the country, which is what we had in that situation.
And the mock-up building, I don't see that in the permit. Does that not need to be in the permit?
I'm sorry, I'm not following you.
The mock-up building,
Check with the simulator?
I've only heard it referred to as a mock-up building.
So, where we've done mock-ups and simulation, those aren't involved in this particular permit change. We have demonstrated the ability to use the system as we're attending here during co-commissioning, but we haven't used it for this purpose. I don't know if you want to add to that.
Yeah, and if there's mock-up buildings, they generally would not be in the permit because those facilities would not be managing dangerous waste.
Good point.
Or radiological waste, so either way.
Yeah, that's a good point. We don't put the right materials in our mock-ups and the hazards, maybe physical hazards like tripping and equipment that you could lift or not lift properly, but so. Other questions?
Well, this is the last question we have in our chat right now, and it's a follow-up question from Mia. So let's see, a follow-up question to my shipment question. Roughly how many gallons of EMF concentrate would be sent per shipment if the law facility is operating at full capacity?
So the tanker truck, and I'm going from memory, but I'm pretty sure it's just under 5,000, so it might be a 4,000 gallon shipment. I believe that's a normal size shipment. And so those would be a single tanker truck that would be your EB3A vessels, it would 3 vessels, it would be about 3 shipments worth. And so it's just the multiples of 4,000 from a per shipment.
Okay, and she asks, at what point in the process does DOE pass responsibility of the waste off to Energy Solutions when the waste leaves the site and goes to Permafix Northwest? When is the waste ultimately disposed of in Utah?
Yeah, so we're responsible for the shipment, that shipment per DOT. And then once it gets treated, then it gets shipped again to the disposal site. So as Suzanne pointed out, there's a specific condition relative to orphan waste. So that our responsibility is to make sure that we don't accumulate large volumes that are not managed to disposal. Do you want to add to that?
Well, I'll ask it maybe a little bit differently. So Department of Energy owns the waste all the way down to the disposal site.
Right.
You have somebody else managing it,
That's
a contractor.
That's correct.
Are there any other questions?
I don't see any other questions.
Any other questions in the audience that we missed? All right, well, we appreciate you being.
Oh, just one more, just
One
slipped in. Okay. From Susan Colton, and she just raised her hand. So did you want to, Susan, did you want to ask your question? By unmuting. And then Liz said she had one follow-up too. So Susan, are you able to unmute Susan Coleman? Maybe while you're doing that, oh, you don't have a question, okay. So Liz, did you? See, it looks like so this is from Liz. What are the transportation impacts once the 4,000 gallons per shipment are grouted? And how many trucks would be on the road?
Yeah, I don't have that level of specificity since we haven't done it the first time. As Suzanne pointed out, it would be 3 times the volume. Over time, we may shift from road shipments to rail shipments, but I can't give you the details of how many. It would be similar from the standpoint of what's the capacity of a truck, but it would be in a grouted form, so it wouldn't be a tanker truck anymore.
And it looks like I did miss one question for Mark. Mark says, is vitrifying 2 million gallons per year a new target to accelerate closure?
No, it's not a new target. We have a consent decree to take the plant to 70% of its overall capacity within the first 3 years. And so we would be ramping up to that level, and it's nominally 2 million. It's not exactly that. It's based on metric tons of glass, but from a feed standpoint, it's around 2 million gallons. So that is not a new one. Although if we find that the plant can support 2.5 million, that's our goal is to get as close to 100% operating efficiency as we can. We will never reach that, but we will get, that's our goal. And to be able to feed the melter. So I will share, and Suzanne can add to this, but during the environmental performance demonstration testing, we saw very favorable results of the melter's willingness to accept feed. So the melters like to be fed. The hard spot is making sure that the exhaust fans and all the abatement train can pull at a negative so that we can feed at a higher rate. And it's not that the abatement train doesn't clear out the contaminants, because it did a very almost, in fact, by the way, I'm very proud of this, almost 10 times as good as it needed to be. Not quite, but almost. And that's a really good thing. That's what we all wanted to do. But the melters show a propensity to like to be fed. And if we can dial in the off-gas system, I'm not gonna make any predictions, but we're gonna feed it as much as we possibly can. I don't know if you want to add to that, Suzanne. All right.
Okay, it looks like that is all of the questions we have. So we want to thank you very much for being here. We will be adding a survey about tonight's meeting into the chat. And then, of course, all of the details about this public involvement, public comment period are on the hanford.gov events calendar. And as you see on the screen and the handouts you received, that is how you submit your comments. Please submit those by April 26th. And thank you very much for being here tonight.
Great job. appreciated your supplement. We got the full. Yeah. There's a good exchange of information, and that was the most harmful likely questions ever. Yeah. it was a good question. County Center. Nice to see you.